circles. Circle keywords.
Ashley.
Okay, good. I got scared. Yeah, I did. I was. I'll look at it in a second. Figure this out. Where do you start? Oh, you're looking at the alright, yeah. Today's my second day being vegetarian. Is it like yesterday's not. My dad's getting it this way. No, I haven't started yet. It's so weird.
Okay, if you did not turn in 91, your homework on slope fields, please make sure you come bring me the hard copy. If you did not put in Google Classroom, I need your hard copy. Okay, and then we are going to continue a little bit more on a worksheet that we started last class, which is 92, so you will need that out of your binder. And if you were working on the back page of that, you might need to move on to a new sheet of paper today. There's not enough room on the original one. So we're going to spend a little bit more time on that since that is the hardest topic from this unit. So again, I'm just trying to spread it as thin as possible, give you as much time as possible to absorb that. But the new thing we'll look at today that we really need to feel pretty good about is the handout y'all picked up, 93, which is over exponential growth and exponential decay type questions. Okay, so our separation of variables, I think we did questions a little bit different than my 6th period did, so y'all have to let me know. I'm pretty sure we did questions 1, 2, 3, and 4. Is that correct? And then not question 5?
For 92?
Yeah.
We did.
We did do 5?
No.
Oh, we did not. Okay. Let's go ahead and pick up with 5. So we're going to do 1 or 2 more of the general solutions, 1 or 2 more of the initial conditions. But again, I'm not expecting you to feel 100% comfortable with this, but because this is the hardest part of this unit, I'm trying to show it to you multiple days instead of just one day and hope that it helps. Now, some of these questions certainly vary in length and difficulty, but what we saw from the questions on Tuesday is all of these you had to separate the variables, which is why it's called separation of variables. You had to integrate on every question. You had to deal with C every question, and you needed to solve for y equals in every question. Now, how difficult that each of those steps were just kind of depends on the question. So, for question 5, remember, if you can't see your dy dx because they do a y prime, go ahead and make that change. You need to be able to see the dy and the dx so that we can separate those. And when we integrate dy, So to integrate, I want y stuff on one side, x stuff on another side, and that includes the dy and the dx, so that it integrates nicely. This one looks like it's pretty easy to separate. If we simply multiply both sides by dx, it has been separated. On an FRQ, you would already get 1 point. Now, sixth period is also a calculus class of mine, and they asked about this constant. I guess if you really wanted to, you could divide this over and put the -1/8 here, or you could leave the -8 here. The constants don't really matter. I usually just leave them alone, just because I think that would add more work. But the purpose of separating is because that should set up our integration to work out pretty nicely. So sometimes the separation, this is about as easy as the separation gets, but if it is harder, it's going to just be some algebra practice. Integrate both sides. Of course, this can be easy to difficult. The most difficult would just be u substitution because it would take us longer. But realistically, we're going to hope that we can just undo the power rule. And then over here, I'm going to cheat just a little bit. I don't really want to do u substitution, but don't be discouraged from u substitution. It's just one extra step, so I'm going to think of it like this. If I did this, what's the derivative of sine of pi x? What's the derivative of sine something? It would be cosine something, not negative. It depends on which way you're going. And so I have that, but because of chain rule, do you see it would also multiply by a pi that I don't want? So I'm just, since it's just a constant, I can just divide that out, and that avoids u substitution. If you don't like to do that, don't risk it. Just do u substitution. Make your u be pi x. When you solve for du, you'll need 1 over pi, and you can make that substitution. But on FRQs, you sometimes get 1 point for that, and sometimes you get 2 points. 1 point for each side. It just depends on the problem. All of these questions, you need to deal with C. So in this problem, we just need to put plus C because it's a general solution. Also on FRQs, you usually get a point for that. And I've also seen FRQs that say if you don't consider C, to take away like give a max score of 2, even if you did everything else right. They punish that quite a bit. And then the last part is always solve for y equals. So for this one, we could multiply everything by 2. Now, an unknown number times 2 is still an unknown number, so I'm just going to still call them C. Yeah.
Would that not be 16 over half?
That would be 2 times. Oh, I'm not dividing by 2, I'm multiplying by 2. You're correct. I was thinking I was making everything 2 times smaller, but yes, 2 times bigger. And then finish with square root. So, part of what makes these questions difficult is you do have to know the steps. Separate, to integrate, deal with C, solve for y. That's going to be consistent in every question. But sometimes the separating is harder than this one was. Sometimes the integrating's more tedious if it's got u substitution. Dealing with C can be more work if it's a particular solution. If it's just a general solution, you just got to not forget it. And then solving for y can be a pain. This one was not too bad. Multiplied everything by 2 and then took the square root. Okay, so this might be the easiest one we look at today. So are you guys okay with how I separated? Are you okay with why I separated? Are you okay with how I integrated? I didn't show you substitution here since it was just undoing one step. I was being kind of lazy, but and you're okay with how I solved for y? Yeah. Okay, let's look at one more general solution today, and then we'll do at least one more particular solution. But whatever we don't get to, we'll do tomorrow. So of course this week was weird with no school Monday, and then this is a B week still for some reason. So I'm seeing you guys 3 times this week. But just keep in mind that next week, even though it is a 5-day school week, I will only see you once because it's an A week, which makes Friday an A day. I'll see you on Thursday. Tuesday is a B day, but Tuesday is the ACT test day. So I might see you in the afternoon. I've not seen the schedule, but if it's anything like years past, I might only see you for 10 or 15 minutes on Tuesday, so not enough time to really do much. Okay, so let's go through this again. First thing I did in the last question is I needed to see the dy dx. So if it is written as y prime, go ahead and make that change. And then all questions, before you integrate, you need to separate. So I can leave the dy over here, leave the x's over here, divide these x's to the other side, and multiply the dx over. You don't have to separate in one step. If that's too many steps for you to do in one thing, then don't risk it. Make it 2 or 3 steps. The accuracy is more important than the speed here. Okay, understand why you're separating, because it's going to make the integration work out nicely. Now what happens to this? What happens if I just integrate dy? What does this become? Just y. This is an understood 1, and the dy, again, this is how we know it's a y, not an x or an r or anything else. Over here, unfortunately, I'm going to put plus c so I don't forget about it. Unfortunately, to integrate this, I can't just undo power rule. So worst case is sometimes we've got to do u substitution. I'm going to pick u to be x squared minus 16. So du would be 2x dx. I need it to be 11x dx. So what do I multiply 2 by to make it become 11? Okay. Yeah, let's try not to do decimals. I think that would make it worse. So if I multiply both sides by 11 over 2, it looks like this guy is the same as u to the negative 1/2, 11 halves integrating u to the negative 1/2 du. Now, I know I'm going over that quickly, but are you guys okay with the steps that I'm doing there? You're okay with the u substitution? Alright, now notice I only integrated one side, but I still needed plus c. So I squeezed it in here so it was technically correct. But now I'll raise the power by 1, divide by the new power. Dividing by 1/2 is the same thing as multiplying by 2. I don't want to leave this as u. He is x squared minus 16. Deal with the c. General solution, dealing with c is much easier than particular solution. You just have to remember it basically. And then the last step for all of these is solve for y. But this one is already solved for y. So again, the difficulty of the steps is just going to vary. Okay, you guys okay with that? Okay, then let's look at least one particular solution, because again, these are a little bit more of a pain because you do have to actually do some work and solve for c, so that can make it more complicated. I guess let's go ahead and try 10. 10 definitely takes up a lot more room, but it might be the hardest one on here, but that's okay. You got to see it at some point. So do not try to squeeze this one in here. Either use the back or move over to a separate sheet of paper. Okay, so what did we do on the last couple of questions that I should do to start off here? I need y'all to give me some feedback so I know what to spend more time on and what we're okay on. Okay, change this to dy over dx. Okay, and then what's the first thing that we have to do in every question? Because sometimes that's done for us. Okay, so this one doesn't look like it's going to separate super quickly. So I'm not going to try to do it in one step. We could maybe add this stuff over. Now, remember, dx and dy can't be in the denominator. That doesn't make sense. They each need to be in the numerator. So the fact that dy is in the numerator here tells me all the y stuff should go to the left. So I'm going to leave this y alone, and I'm going to divide this y stuff over. I'm going to leave this x alone, and I'm going to divide this other x stuff over, including dx. So that's definitely one of the messier separations. As long as you're not trying to do some math rule that doesn't really work, it should be fine. If you need 5 steps instead of 2 steps, that's fine. Okay, everybody up to speed here? Okay, what was the purpose of separating? Because that's your hint on what to do next. Okay, it makes it where integration works out nicely. Now, to integrate this, obviously this is not just undoing the power rule. You actually have to do your substitution. I'm going to spare you just a little bit here. I already worked this one out, so I did use substitution, and let's just pretend like we did that. This comes out to be negative square root of 1 minus y squared. And I obviously don't want to do u substitution unless I have to. But what's one kind of nice thing about when I do this u substitution? Do I have to do u substitution again over here?
Same thing.
Yeah, it's the exact same thing, but it has x's. So luckily, you kind of get to double dip on your work. Double dip on your u substitution if you're paying attention. Now, what's going to be more difficult about these questions is dealing with C. Not only do you need to remember to add to plus C, but they give us an initial condition that helps us solve for C. So my rule of thumb is the second that I see C, I'm going to solve for it and then plug it back in. In theory, and I'm going to try to do that for consistency, in theory you can try to simplify this sum, like maybe multiply everything by a negative to make these negatives go away, and then solve for C, and that's okay too, but wherever you start solving for C, that's where you need to plug it back in. So don't multiply everything by -1, solve for C, and then plug it into this step where you didn't do that. You just have to be consistent. So if I plug in 0 for x, it looks like this goes to -1. If I plug in 1 for y, it looks like that goes to 0. So when I started solving here, C is 1. So I need to plug it back into where I started solving from. So that's what I mean by solving for, or dealing with C. Can be as simple as throwing on a plus C like we saw in the first 2 questions, but sometimes it takes a few more steps. You might actually have to solve for C and plug it back in. Okay, and then what's the last part of all of these questions?
Solve for y.
Okay, and this isn't going to be difficult, but it is going to take a few steps. We can multiply everything by a negative. We could square both sides. Now when you square this side, that doesn't mean that you just get to square this and then square this. You have to square the whole thing. That's not how FOIL works. We could subtract 1 from both sides. We could multiply both sides by a negative. As I said, none of this is hard, it's just very kind of tedious. And then finish with square root. So those last 1, 2, 3, 4, 5, 6 steps, I undid timesing by a negative, I undid squaring, I undid a +1, I undid a times by a -1, and then I undid a square. So it looks way harder than it really was. But usually, and I'd be very surprised on our next test, still a couple weeks away, but again, you know, I don't see you much next week. I'd be very surprised if we did not give you an FRQ that has one of these, because these have been showing up pretty regularly the last few years, and this is at least 5 points on an FRQ. Over half the points could be just this one part that they ask. I mean, there could be a part A and a part C and B, and this could be part C. But usually 1 point if you separate the variables correctly. Usually 1 point if you integrate. Sometimes 2 points for each side. Usually 1 point if you think about C and put plus C. Usually 1 point if you actually solve correctly for C. And then 1 point if you can get all the way down to y equals. So again, this is a skill that people worry about the most. But my advice to you on the FRQ, if you saw this on the AP exam, you should be happy. It might be hard to get this last point, but it's usually not that bad to get the first 3, 4, 5 points. You're okay with all that? This 20-step question, no big deal? Okay. I'll show that to my pre-calc classes tomorrow so that they'll be scared of calculus. Okay, do you want to do one more of these, or are we done with this for now?
Let's be done.
Okay, let's be done. That just means more tomorrow. You're going to be here tomorrow. She's only saying that because she's not...
Videos for these, right?
Not for this. Not for the notes handout. But we will finish this tomorrow, and then I've got a book assignment for you to try a few, and I do have videos of all of those. So you don't need to feel like you've mastered that yet. I mean, I guess if you feel completely clueless on it, you might look ahead on my website to the book assignment and start trying some of the easier questions and watching the videos to help you get over the hump. But again, I'm just trying to break it into a million pieces, because it's a hard thing to just spend one class on and say, I hope you've got it. So, okay, but our main focus today is going to be over this exponential growth and exponential decay stuff. And this is not that different. It's very similar to the same exponential growth and decay that you even did as back as Algebra 2 and should have reviewed it in pre-calculus. Now, one thing is, they like to write it like this, and that's fine, but just so you know, this is the same thing, and this is how I'm going to word it, because you probably not have seen this before. Do you remember this PERT formula? That's a good one to know for the ACT if you've forgotten it. This is basically the PERT formula. You've got an amount. You've got a starting amount. Y sub 0 is kind of more of a scientific way to say the amount at time 0. But in math class, we usually call that principal P. We've got the number E. Sometimes they call it K. Sometimes we call it R, but it's the same thing. And then T. So for these questions, what you should notice is that they will all have the same wording. This is how you're going to know that it's this type of question. If it says it changes at a rate proportional to the amount present, or if it writes it in calculus terms. If it says that, then it is a PERT question. So what I'd like to do is start you off with one of the harder questions. This one. This is a previously released question, so I can show you what we're aiming for. But then we're going to flip it over and start on the back. The back starts off with much, much easier questions and slowly build you up to these release type questions. Okay, so what they will ask you to do on the AP exam, and there'll only be 1 or 2 of them on there, but we want to make sure that you can do these. It says bacteria in a certain culture increase at a rate proportional to the number present. That's how I know this is a PERT type question. If the number of bacteria doubles in 3 hours, in how many hours will the number of bacteria triple? Okay, so as soon as I read that in red, I know it's this type of question, and then I'm going to plug in what they tell me. They tell me that it doubles in 3 hours. So that means T is 3 hours. They didn't tell me the starting amount or the ending amount, but here's why it doesn't matter that much. Just pick a starting amount. How many bacteria do you think we're starting with? Did you say 20? Okay, if it's 20, how much is it going to be when it triples?
Let's do 1 actually.
Okay, I am going to do 1, but I want y'all to see why it doesn't matter. If this was 20, this would need to be 60. And your first step, if you do that, is divide both sides by 20. So 1 and 3. Yes. Whether you start with 1 and 3 or 20 and 60 or 2 million and 6 million, if you undo that first step, you might as well just pick low numbers. 1 and 3. It's 3 times bigger. So if we plug that in, that allows me to solve for R, but we have to use a little bit of logarithm stuff. So if you want to solve for a variable in the exponent, the only way to get that out of the exponent is with logarithms. And in calculus, we always use natural logarithms. Other logarithms are okay, but we just don't use them as much. So if I was to take the natural log of both sides, on the left side, I've got a number. What happens with this? This is what I'm concerned about, if y'all remember a certain property. What can I do with this? Okay, so then you need to put a star by this. If you haven't, yeah.
Shouldn't it be equal to, like, instead of 3, should it be 2? Because it's doubling in 3 hours?
Oh, yes, sorry. The number of bacteria doubles in 3 hours. I'm sorry, this should be a 2. If it doubled, this would be 2. Okay, if you have an exponent on something you're taking the log of, that exponent can come down out front. And what is natural log of E? So if I divide this side by 3 and divide this side by 3, I have solved for the rate. I solved for the one thing I could have. Now, this question didn't ask you to solve for the rate. This is why this one's a little bit harder. This is what we're going to aim for by the end of class. If I start over, and how many hours were the number of bacteria triple? So if I start off with 1 and 3 or 1 million and 3 million, doesn't matter. Now that I know what R is, I can plug that in and we can solve for time. We can figure out how much time that has to be. That's going to have very similar steps. The only way you're going to get a variable out of the exponent is with logarithms.
Wait, isn't it 2? Instead of 3? Yeah, we said double.
This 3?
Yeah.
Well, no, I'm on the second half of the question now. And how many hours will the number of bacteria triple? So they told me it would be 3 hours for it to double, so I did 1 and 2 to solve for the rate. Now that I have the rate, I can plug it in and solve how much time it takes for it to triple. So 1 to 3. So once again, this is the one that y'all didn't speak up on. If you have an exponent on something you're taking the log of, all of this gets to come down. natural log of E is just 1. So I could multiply both sides by 3 and divide both sides by the natural log of 2. And that looks like it is choice A. So we had to do PERT one time to solve for the rate, plug it back in, do PERT again once we knew the rate to solve for the time. But there's two things going on in here. Sometimes you got to consider taking the natural log of both sides so that you can get the variable out of the exponent. And if you don't remember this property that I have highlighted, then you don't know why you're doing that and you're not going to remember it anyway. A variable or an exponent on something you're taking the log of can come down out front. In fact, this is what we're doing in pre-calculus right now, and I think the daily meme kind of shows that off if the website's working. Okay, so you see how like this is an exponent sort of? And since it's an exponent on something you're taking the log of, the exponent can come down out front. That's basically what we're doing, but with numbers and variables. Okay, so again, this is what they expect you to do on the AP exam. This is the harder version of the question because you're basically having to do it twice, but that's what we're going to build up to. Let's reset and skip all the way to the back page where the questions are much simpler and slowly work us up to that. But we'll be using some of the same stuff. Okay, I would like you to read through and try both parts of question 1. And I'd like you to try that before we go over it. You will need a calculator on a few of these too, by the way. Let me give you a few minutes to get there, but I'll also share my answers with you. So if you are getting these answers for number 1, you can move along and not have to wait on us. Okay, so if you did not get 13.591 for part 1, it just wanted to know the weight after 10 days. So notice they gave us a little equation to use, just a different version of PERT, but it's still the same thing. So what is the amount if he starts off as 5 units? His rate is 0.1, and you want to know after 10 days. And then throw that in your calculator. And that's where my 13.591 comes from. Okay, and then for the time for it to weigh 10 units, so you know how much he starts off with, you know what the rate is, you want to solve for time when he becomes 10 units. So the first thing you should do is divide both sides by 5. And now here's one of those steps that we did on the other side. You need to, the only way you're going to get t out of the exponent is if you take the natural log of both sides, so that there's a variable, an exponent on something that you're taking the log of, because then that can come down out front. And in the end, natural log of e is just 1, so t comes from the natural log of 2 divided by 0.1, which is where 6.93 came on. So, had to take the natural log of both sides, so that this was an exponent on something you're taking the log of, so that it can come down out front. But as you guys saw from the harder question on the front page, we're going to need to do that sometimes. So make sure that you are okay with that question before you move on, because again, they will slowly kind of ramp up in difficulty. But then move on to question 2 once you feel okay with question 1. Got just a minute here, so finish up what you're working on and find the stopping place. Okay, let's pick back up wherever you left off there. So, as I had on the agenda, I am going to ask that you guys finish this up, and with this being a B week, I will see you again tomorrow, so we need to get back on track here pretty quickly. So, I posted, well, first off, the website has all the answers, so those of you that work quicker, you do not have to be at the mercy of everyone else's speed. But when you finish question 2, make sure you're coming up with those 3 answers, and then move along quickly, please. And if you're not coming up with one of those, then I will help you. And if it seems to be a common problem, we can do it on the board. But in the next couple of minutes here, I will need you to tell me if there's some of those you need help with. But you do have to recognize that that's a decimal, and if you write it as a percent, that's not 0.02%. Anything on number 2? Finish it. Stuck? Okay. Okay, it looked like people were either finished with number 2 or almost finished, so just to keep you moving along here, I'm also going to write up the answers to number 3.
population do you round up to the highest number? Since you can't have like a 0.97th of like a person, or do you just leave it at like 0.97?
I'd probably still round to the nearest person,
Okay.
personally, but I tend to round 3 decimal places just because that's what the AP exam expects, but
Okay.
I know what you mean by. And then when you get to question 4, it has a similar similar work to the question number 1 we did on the front. You'll have to do it in 2 parts. So you might need to look at question 1 again before you try question 4. Okay, any part of question 2 or question 3 I can help with that I can work out for you? Okay, let me give everybody another minute or two to have attempted question 4, and then I will offer to work that one as well. Let me go over number 4. So, if you've not decided to pull up the solutions online, quickly make sure that you ended up with 1,378.585 before you tune me out here. But if you got that for question 4, go ahead and continue. Finish up the back page so that you can go back to the front page. Again, all the questions on the front page except the front one are actual released multiple choice questions. So it gives you a good idea of what they will expect you to do on the calculus exam, the AP exam. Now, to be fair, they're only going to put 1 or 2 of these on there, but still, you want to be able to make sure that you get them. Okay, so question 4, how I did this. First off, it says this on the back page. This is the first one that did not give me a formula to work with, but it said the food increases at a rate proportional to the mass. That is what is telling me it's this type of question, and not derivatives, not integration, not limits, not something else that we've ever done. That is the big key to start off with this. Okay, if during 1 hour it increases from 100 micrograms to 130 micrograms, so I'm plugging 1 in for T. T is in terms of hours in this question, it looks like. Starting amount goes in for P, ending amount goes in for A. This only gives you enough to solve for R, which is not what the question's asking for. That's why the answer is not quite as simple. But you can divide both sides by 100, and then that should give us 1.3 is equal to the e to the r. I had to do this on the question on the front page, and I don't, well, I take that back. You did have to do this once at least before this question. The only way to get a variable out of the exponent and solve is with logarithms. This is why logarithms are important. So you need to take the log of both sides, preferably natural log. So then r is an exponent on something you're taking the log of, so r can come down out front. Natural log of e is just 1. And so all of that was to figure out that the rate is the natural log of 1.3. But that's not what the question is asking for. The question is, what's the mass in 10 hours? But now that you have this, you can reset. We know the starting is 100. Now we know the rate is natural log of 1.3. And we want to know how much mass, what's the amount of mass if it was 10 hours later. So you can plug in T for time. And then it's ready to be thrown in the calculator. And that is where I got the 1,378.585 micrograms. So this is a little bit closer to what the AP test will expect you to do. Plug in some information, solve for R, plug it all back in with some different information, and solve for something else. Yeah.
Will they count you off if you round earlier in the equation? So if you solved like the natural log of 1.3 is the rate, and then just put that rounding into the equation?
Yes.
So they won't count you off for it?
Well, multiple choice, the problem is on multiple choice, if you round early in the question, your final answer is going to be off. So you don't know, should you just pick the one that's close to this, or is it that you made a mistake and you need to redo it? So you're going to have some confusion there. But yes, on free response, they expect it to be within 3 decimal places being accurate. So was it this that you typed in the calculator and got a decimal?
Yeah.
Yeah, if you round that too early, I just kept it exactly the same thing, and I just plugged it in the calculator exactly like it looks. If you want to do that, if you want to do this, don't use the rounded amount. Do you know how to use the store button?
I can just use the answer button.
That's true too, if you can get it to spit out your answer in the next step, yeah. But also you can use this button down here above on, and like you could store that in for any letter. And so then anytime I say R, it's not rounding, it's keeping up with the exact amount. So then you don't have to worry about it, if you think that's easier. But yes, do not round until the very, very end. Other questions about 4? Okay, and let me give you a few minutes to keep going. But I think the answers to 5 should be 1,960. Has anybody done 5 yet?
Yeah, that's right.
Okay, what about 32.651?
Yeah.
Okay. I used to have a mistake on one of those questions, but I guess I fixed it. So go ahead and finish 5 if you haven't yet. Make sure you get that answer. If you can't figure out what it is, then please be ready to ask. And of course, one of the nice things about these questions are, like, I know you have to know a couple logarithm things, consider taking the natural log of both sides, know how to bring the exponent down. But truthfully, like, this isn't, like, we're not having to do derivatives or integrals. We're not having to do any real calculus to get these answers. The only thing I can think of that is calculus related on this was this at the start. Sometimes instead of words of saying it changes at a rate proportional to the amount present, sometimes they might write it like this as a derivative. These two mean the same thing. So sometimes they might say words that show you that it's a PERT problem, and sometimes they might say this, which tells you it's a PERT problem. But other than that, you're not really having to use any calculus. Okay, any parts of question 5 you'd like me to go over with you? Part A or part B? Okay, I'll stop bugging you, but please make sure you're checking your answers with the solutions online, either as you work or as you go. If you guys do find a question while you're still here, you got about 13 minutes, so please speak up and let me know so I can help you. Otherwise, if you need help, make a plan to come see me during advisory tomorrow. And for homework, please finish up whatever you don't have time to get to in class. rounding before you go to the end, maybe? I don't know. If you didn't erase your work, I could maybe look at it.
Well, you didn't have that work on you.
Oh,
Something like it.
okay. Well, I still don't know how to help you because I don't know what you did. Did you get it?
No. I don't know this stuff.
Wait, let me see. So starting around. Thousand. Why did it say 10?
Where, so, in this year, it has this many people, so you know the amount is this. When T was 10, well, what about the starting amount? Where's your, the P part of your from?
Oh, it's just kind of disappeared.
Your starting should be 1,000, so you should have 1,000 right here, which
okay.
is gonna make that like 1.4 on the other side.
Okay. And then I should have variance.
Well, I don't know, I just know that that's not the.
Okay. I didn't have anything on that, right? Zero. I didn't have one. Maybe you did that right.
Alright, you guys have about 5 minutes. So you might want to finish up the question you're on and find a stopping place. Again, I apologize that it's a quick turnaround, but that's just the way B weeks are gonna go when I see you on Thursday and Friday. But if you need help finishing, make sure that you come see me during advisory tomorrow.
Okay.
And I'm also putting it in Google Classroom, so if you want to turn it in before you come to class, you can.